All right, good afternoon, everybody. Hope you're doing well. This is my last video, and there were two that had the same number, and this one is certainly more realistic to do right now. So I thought I would do this one. It says, how many positive integers n, this is section 4.5, number 11, how many positive integers n divide this thing? Now, before I do this, I did put out a request to the last video, and if you've been watching these, please shoot me an email and just let me know that you've been watching them and enjoying them and finding them useful. I might do more, so let me know. But let's go about this. So first thing I've done is I've factored that second number, and you'll see why in a sec. So what I'm looking for is the number of positive integers that divide this thing. Now, it's written on two lines there, so I'll write it on one line just to make it a little more clear. The number of positive integers n that divide this whole number. Well, here's the thing. There's an n there, right? And so if there's an n there, then this whole term is divisible by n. Clearly, a multiple of n, right? Completely obvious. Now, the only way the whole thing is then a multiple of n is that this needs to be a multiple of n. And if that needs to be a multiple of n, well, that limits what n can be. And this is why the prime power decomposition of that number comes in very, very important. What I need is then n needs to be a factor of that number. Well, how many factors are there? Now, I did not do this theorem explicitly in my class, but I think the book does it. And if not, it's a very clear counting argument. How many factors does this number have? Well, any given factor of it may or may not have a 2 in its prime power decomposition, right? If it does have a 2, it can have at most 8 2s. It can't have 9 2s. It wouldn't be a factor anymore, right? 2 to the power of 9 is not a factor of this. But it can have 0 2s, 1 2, 2 2s, 3 2s, 4 2s, all the way up to 8 2s. So the first thing to choose, how many positive factors of 2 to the 8, 3 to the 6, 11 to the 3 are there?
Hey guys, if you are looking for help with learning discrete math or proofs, I know they're tough, then make sure to subscribe, as I'm literally going to be posting every example I have here for free on YouTube to help you learn and understand discrete math proofs. Back to the example.
Well, first, how many 2's are in the factor? There could be 1, 2, 3, 4, 5, 6, 7, or 8, or 0. There are 9 choices. Number of 2's, or I should say, power of 2 in the decomposition. Once you choose the power of 2 there is, well, then you equally have to choose the power of 3 there is. It could be, again, 3 to the 0, or 3 to the 1, 2, 3, 4, 5, or 6, and that's it. So there are 7 choices. Spread that out a little bit. Power of 3. Oop, not 3, my bad. 7. There are 7 choices there. 3 to the 1, 3 to the 2, 3 to 3, 3 to the 4, 3 to the 5, 3 to 6, or 3 to the 0. No 3's. And then, once you choose the power of 2, once you choose the power of 3, you then choose the power of 11, and there are 4 options there. Right? Again, it could be 11 to the 1, 11 to the 2, 11 to the 3, or 11 to the 0. Okay? And so that number, whatever that equals, what is that? 9 times 7 is 63. 63 times 4. 252. Hope I did that right. And so there are 252 positive factors of this number on the right. Every one of them will always be a factor of the left if that's the n value, right? if every one of those 252 n values can be a number for n, and then it will divide the left term and it will divide the right term. Therefore, it will divide the whole thing. And that's it. That's everything. Those are all the numbers that'll divide the right term. Therefore, that's all the possible numbers. Be any one of these 252 numbers. Positive numbers. They're all positive. The smallest one is 1. Where's the 1 show up? If I chose the power of 2 I chose was 0, the power of 3 I chose was 0, and the power of 11 I chose was 0. In other words, I chose 2 to the 0, 3 to the 0, 11 to the 0. Well, that's something to the 0, something to the 0, something to the, it's all to the power of 0. That's 1. And that's it. How many positive integers divide that? The answer, 252 positive integers. I hope that's right. It seems right to me. Okay, so we'll leave it there. Have a good one. Good luck to you, and please shoot me an email and let me know how if these were helpful for you. Thanks so much.
Hey, thanks for watching. Remember, what I've explained here is just a tiny, tiny example in the literally infinite space of problems there could be that you'd run into. So, if you're interested in really understanding this content, getting a good grade because you understand the content, go ahead and click the first link down below and book a free call with me, and let's talk about if I can actually help you do well in this course.